This is the lecture for Math 1508 Pre-Calculus at UTEP, Chapter 1, Functions and Their Graphs, Section 1.1, Rectangular Coordinates. This goes along with Larson's Pre-Calculus 10th edition. So here we go. Alright, so the Cartesian coordinate system is named after a French mathematician named René Descartes. And what he did is tried to make algebra a little more like geometry so we could see it. So he took one number line, laid it horizontally, and we called that the x-axis, and a second number line, and laid it vertically, we call that the y-axis, and these two number lines meet at their zeros. So now every value in an entire coordinate plane, so any flat surface, two-dimensional surface, we can find by coordinates. So we label the x-axis, x comes before y alphabetically, horizontally comes before vertically alphabetically. The x-axis is the first coordinate, and the second coordinate is from the y-axis, so we can talk about the distance to the right, the distance to the left, followed by the distance up or the distance down. When we put these two number lines together, it divides the plane into 4 quadrants. Quadrants generally named via Roman numerals, and it follows the pattern of the rising sun. So it starts in the east, rises to high noon, so that's quadrant 1, comes back over, sets in the west, quadrant 2, and then the sun has to reset, so we have quadrants 3 and 4. Here's an example. So this point A is 2 units to the right, 1 unit up, so we call that the point 2, 1. The point B, starting at the origin, is 1 unit to the left, and then 3 units up, so we call that point -1, 3. The point C is 3 units to the left and 3 units down, so that will be -3, 3. And the point D is 4 units to the right, but it does not go up, it does not come down from the axis, so it's 4, 0. Now that we know coordinates, we're going to use these and the Pythagorean Theorem. It's one of the few theorems that just about everyone walking down the street knows the name of. But really, we only remember the a squared plus b squared equals c squared. There's another important part of it. This is only true for a right triangle. So for a right triangle with hypotenuse length c and sides length a and b, you have a squared plus b squared equals c squared. The converse is also true, which means that if the equation holds, then the triangle has to be a right triangle. And we're going to use this as we do some future examples. Using the Pythagorean Theorem, we're going to come up with the distance formula. So if I have any two random points, here's a point x1, y1, and if it's moved x1 units horizontally and y1 units vertically from the origin, the point x2, y2, and I want to find the distance between them. We can think of, in blue, the distance between the x's, as our a, in green, the distance between the y's, as our b, and our distance here as c. So we have a squared plus b squared equals c squared. But we don't want to know what the distance squared is, so we'll take the square root of both sides, and we end up with the distance formula. The distance d between points x1, y1 and x2, y2 in the plane is, the distance is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. We're going to use this formula several times. So let's find the distance between the points 8, 5 and 20, 0. In order to find the distance, we'll subtract the x values, 20 minus 8, and then square that. Add to it the distance between the y values, 0 minus 5, all squared. 20 minus 8 is 12. 0 minus 5 is a -5. Notice I put the -5 in parentheses to make sure it all gets squared. 12 squared is 144. -5 squared is 25. Combine these, I'll have the square root of 169, which is a distance of 13 units. If you have a perfect square, simplify. Example number 2. The distance between -2, 6 and the point 3, 4. We'll subtract the x's, a 3 minus a -2, all squared, plus the distance between the y values, -4 minus 6, all squared. So that's 3 plus 2, which is 5 squared, which will give us 25. Negative 4 minus 6 is a negative 10. All squared will be 100. And we'll have the square root of 125. Now 125 is not a perfect square, like in our first example. So we need to simplify it. Remember, when you're simplifying a radical, we use the product property. I know that 125 is 25 times 5, and I chose 25 because it's the largest perfect square that goes into 125. The square root of a product is the product of square roots. So the square root of 25 is 5 times the square root of 5. Give it a shot. You try it. I will fill in the answer for you. But pause. Make sure you're able to find that the distance is 3 square root of 10. If you can't do it, make sure you let me know in class and we'll take a look at this. Alright, so now I mentioned we're going to use the converse of the Pythagorean Theorem, and here it is. Show that the points form the vertices of a right triangle. So our strategy is to verify that these are right triangles. We can use the converse of the Pythagorean Theorem. So we're going to find the distances between all 3 points, AB, AC, and BC, and determine if the Pythagorean Theorem holds. That is, if a squared plus b squared equals c squared. One thing we'll want to keep in mind is the hypotenuse is always the longest side, so our c value, double use of our ABC here, we'll make sure our c value is the longest or the largest value of distance. Alright, so number 1, a equals the point 4, 0, b is the point 2, 1, and c is the point -1, -5. So we find the distance between a and b. Subtract the x values and square it, subtract the y values and square it, and we end up with the square root of 5. Now we'll find the distance between a and c using a and c. The difference in the x values, -1 minus 4, all squared. The distance between the y values, -5 minus 0, all squared. We end up with the square root of 50. Now the square root of 5 we cannot simplify. The square root of 50 we could. But remember, we're using the Pythagorean Theorem. We're going to ultimately square these. So let's just leave them in radical form. So the square root and the square makes things easier for us in the end. The distance between b and c, I'm going to take 0.21 and the point -1,5, subtract the x values, subtract the y values, square the results, add, and I'll have the square root of 45. The hypotenuse always the longest side, so square root of 50 will be larger than either of the other two. The square root of 5 squared plus the square root of 45 squared, does that equal the square root of 50 squared? Absolutely. 5 plus 45 equals 50. Second example, same thing. The distance between a and b, 3 minus a -1. The distance between the y values, 5 minus 3. Subtract, then square, add, and we'll have the square root of 20. The distance between a and c, I'm going to take 5 minus a -1, 1 minus a 3, square them. 36 plus 4 gives me a 40 underneath the radical. This is called the radicand, just in case I use that term later. The thing under the radical, official term, radicand. Now the distance between b and c, 5 minus 3, 1 minus 5, square the results, add the results of that, square root of 20, and 40 is the largest value. 40 is going to be our hypotenuse. The square root of 20 squared plus the square root of 20 squared is the square root of 40. So this is also a right triangle. It will not always work out, but frequently, in order to show this, we make them work. The midpoint formula, think of this as an average. That's all it is. If you're given 2 points, you find a halfway point on the x coordinates and you find the halfway point on the y coordinates. So for 2 points, x1, y1, and x2, y2, the midpoint is given by add the x's, divide by 2, comma, the second coordinate, add the y values, divide by 2. This does come from the distance formula, as it turns out. If you want more information from that, consult the textbook. Alright, let's look at some examples. If I want to find the midpoint of the point 813 and the point 16, -5, I will add the x values, 8 plus 16, and then divide by 2. Comma, I'll add the y values, 13 and -5, then divide by 2. It's a point, right? So I have x, comma, and then I have a y. 8 plus 16 is 24, still divided by 2. 13 plus a -5 is 8, still divided by 2. 24 over 2, comma 8 over 2. Let's simplify that. Always simplify your fractions if you can. 24 over 2 is 12, and 8 over 2 is 4. Second example, the midpoint, -1, comma 3, and 4, comma -10. -1 plus 4 over 2 gives me 3 over 2. 3 plus a -10, that's 3 minus 10, is a -7 over 2. And I'm going to leave them. I know some of you would love to write 1.5, comma -3.5. But that's just more work, right? Well, what's the decimal? Well, you already know what the fraction is. Leave it like that. Get used to using fractions. Many times it is preferred over any decimal value. That's the end of the lecture. We'll move on to the next one.